Look up. That blazing ball of light in the sky is the sun. It's not just any star, it's our very own star, the heart of our solar system. Life on Earth wouldn't exist without it. The sun bathes us in light and warmth. It provides the energy for plants to grow. These plants, in turn, feed us and every other living creature on our planet. The sun is a powerful force. It governs the motions of all the planets that orbit it, including our own Earth. Without the sun, our world would be a very different place, a cold, dark, and lifeless void. So, what is the sun made of? Imagine a giant ball of gas, mostly hydrogen and helium. These are the two lightest elements in the universe. But the sun isn't just a giant gas cloud, it's a plasma. This means the atoms are stripped of their electrons, creating a sea of charged particles. This plasma is constantly moving and churning due to the intense heat and pressure inside the sun. The sun's immense gravity pulls all this material inwards, creating extreme conditions at its core. These conditions are the key to the sun's power, the power to create light, heat, and ultimately life itself. Let's take a journey inside the sun. Picture it like peeling back the layers of an onion, each layer with its own unique characteristics. At the very center lies the core. This is where the magic happens. It's unimaginably dense and hot, reaching temperatures of millions of degrees. Moving outward, we encounter the radiative zone. Here, energy generated in the core slowly travels outward in the form of light. It's a long and arduous journey for these photons. Next comes the convective zone. Think of a boiling pot of water. Hot plasma rises to the surface, cools, and sinks back down. This creates a churning motion that transports energy. Finally, we reach the sun's visible surface, the photosphere. This is the layer we see from Earth, a blindingly bright sphere. But there's more. Above the photosphere lies the chromosphere, a thin layer visible during solar eclipses. And further out, a wispy halo called the corona extends millions of kilometers into space. Each layer plays a crucial role in the sun's energy production and its influence on our solar system. Deep within the sun's core, an extraordinary process unfolds. Nuclear fusion. Imagine hydrogen atoms, the simplest atoms in the universe, colliding with such force that they fuse together. This fusion creates a new element, helium, and releases an incredible amount of energy. It's like a cosmic hydrogen bomb, but one that's been exploding continuously for billions of years. This energy, in the form of light, slowly makes its way through the radiative zone. Think of it as a game of cosmic pinball with photons bouncing off atoms for thousands of years. In the convective zone, the energy transfer becomes more dynamic. Hot plasma rises like bubbles in a boiling pot, carrying energy to the surface. Finally, this energy bursts forth from the photosphere as sunlight, the lifeblood of our planet. It's a journey that takes millions of years, but without it, we wouldn't be here. Section 5, solar storms, sunspots, flares, and ejections. The sun isn't always calm and predictable. Like a pot boiling over, it can unleash bursts of energy and matter into space. These solar storms can have dramatic effects on Earth. Sunspots, those dark patches on the sun's surface, are cooler regions caused by intense magnetic activity. They are often associated with solar flares, sudden bursts of energy that release high-energy radiation. These flares can disrupt radio communications and even damage satellites, but even more powerful are coronal mass ejections, or CMEs. CMEs are massive eruptions of plasma and magnetic fields from the sun's corona. Imagine 1 billion tons of material hurtling through space at millions of kilometers per hour. When a CME hits Earth, it can trigger intense geomagnetic storms, disrupting power grids, causing auroras, and even posing risks to astronauts. Section 6. The solar wind. A cosmic breeze. The sun is constantly shedding its outer layers, releasing a stream of charged particles into space. This constant outflow is called the solar wind. The solar wind is like a cosmic breeze flowing past all the planets in the solar system. It carries with it the sun's magnetic field, creating a vast magnetic bubble called the heliosphere. This bubble protects us from harmful cosmic rays, high-energy particles from outside our solar system. It acts like a shield, deflecting these particles away from Earth. But the solar wind can also be disruptive. When it interacts with Earth's magnetic field, it can create beautiful auroras. also known as the northern and southern lights. These shimmering curtains of light are a reminder of the constant interplay between the sun and our planet. Section 7. The sun's magnetism and its rhythms. The sun is like a giant magnet, but its magnetic field is far more complex than Earth's. It's constantly changing, with magnetic field lines twisting, breaking, and reconnecting. This dynamic magnetic field drives the sun's activity, including sunspots, solar flares, and CMEs. It's all part of a natural cycle known as the solar cycle. The solar cycle lasts approximately 11 years. During this cycle, the sun's magnetic field flips polarity, with the north and south magnetic poles reversing positions. At the peak of the solar cycle, known as solar maximum, the sun is at its most active, with more sunspots, flares, and CMEs. During solar minimum, activity is much quieter. Understanding the solar cycle helps us predict and prepare for potential impacts of solar storms on our technology and infrastructure. Section 8. The sun's fate. A glimpse into the future. The sun won't shine forever like all stars. It has a limited lifespan, but don't worry, it has billions of years left. Right now, the sun is in the prime of its life, steadily fusing hydrogen into helium. But eventually it will run out of hydrogen fuel in its core. When this happens, the sun will begin to change. It will expand dramatically, becoming a red giant star. Its outer layers will engulf the inner planets, including Earth. But don't despair. By then, humanity may have ventured beyond Earth, establishing new homes among the stars. Eventually, the sun will shed its outer layers, leaving behind a small, dense core called a white dwarf. This stellar remnant will slowly cool down over billions of years, eventually fading away into the darkness of space. The sun's story is a reminder of the vastness of time and the incredible cycles of birth, life, and death that govern the cosmos. And while our sun's time is limited, its legacy will live on in the countless stars that illuminate the universe.